Hello, Math 1100 students. This is your last lesson for Chapter 13, and it is about quadratic equations and problem solving. And we will begin with an example. The length of a rectangular garden is 5 feet more than its width. The area of the garden is 176 square feet. Find the length and the width of the garden. Well, here we've got a picture of the garden. Sometimes the picture helps us more than anything else does. And since we don't know what the length and the width are, then we're going to have to figure out variables to represent those. The one thing that we do know that we are told is that the length is 5 feet more than the width. So if we were to call this the length, and we were to call this the width, we know that the length is the width plus 5 feet. And then the other thing that we know is that the area of the garden, which would be everything that's inside this rectangle, is 176 square feet. And that's because we would have feet times feet. The formula for this would be that the area is equal to the length times the width. And since we know that, and we've assigned variables now, we know then that the length is equal to W plus 5. And we know that the width is equal to just W. And we are told that that product is 176 square feet. And now that we know that, then we can multiply out the product of these two, and get that W times W is W squared, and W times 5 is plus 5W, and that is equal to 176. So then we would subtract 176 from both sides, in order to have this set equal to 0. And so what we need to do to finish the problem now is we need to solve that quadratic equation. And the only method we have right now for solving that quadratic equation is by factoring the quadratic expression. And so our product that we're going to have to figure out factors for, since the coefficient of W is 1, then A is 1 and C is negative 176, which gives us 176, and it's negative. And the negative sign tells us that we will have one positive factor and one negative factor. And since it is the positive middle term, we need the larger of the two numbers to be the positive number. And so when we start listing our factors, the smaller factors are all going to be negative. So I'm going to start listing some factors. And -1 plus 176 is your first set of factors. And of course, that's not +5. -2, and let me grab the calculator to make this go a little faster. Is 88, which of course is still not even nearly what we need. And 176, I don't think can be divided by 3. Nope. It is divisible by 4. It isn't divisible by 5 because it doesn't end in 0 or 5. Since it wasn't divisible by 3, it's not going to be divisible by 6 either. You can check that out. And since it wasn't divisible by 3, it also isn't going to be divisible by 7. Might be divisible by 8. And it is. That would be -8 and +22. But still, not close. And so, I'm going to keep trying some numbers here until I come up with the next one that works. $11 works. -11 and +16. And since -11 and +16 equals +5, we have found our set of factors. And so at this point, I'm going to erase some of this. To give us the room to actually do our factoring. And so here goes our factoring. And so we have W, which is squared, and -176, and then -11x in one box, and +16x in the other box. And we find our greatest common factors. I'm sorry, I put in W's and then put in X's. I'm sure that was confusing. Those are all W's. And across the first, we have W is in common to both W squared and 16W. And we have a negative in common to both negative 11W, and negative 176, and we know that 11 divides 176, so that's going to be minus 11. And then in our first column, we have W in common to both those factors, both of those terms. And then between 16 and 176, that's going to be 16. And so we multiply it out just to check and make sure we have everything right. And W times W is W squared. 16 times W is 16W if that W is positive. And so we'll make it positive. Negative W, or negative 11 times W is negative 11W, and negative 11 times positive 16, we've already established, is negative 176. And so our factors then are W minus 11 and W plus 16, and that product is equal to 0, which means either W minus 11 is equal to 0 or W plus 16 is equal to 0. And this provides us with a solution that really isn't a logical solution, since we know that distances can't be negative. But W equals 11 tells us the answer to the problem. And so in order to answer the problem, I'm going to return to the top where I have room to write, and I'm going to answer the question. And the answer to the question is the length of the garden is 16 feet, and the width, which was W, is 11 feet. And we know that's 16 feet because 11 feet, from this formula here, this declaration of variable, 11 plus 5 gave us 16. So remember, the last step for solving any word problem is to actually write out the answer to the question in a sentence. Now, I'm going to skip over these problem-solving steps and just actually work the example problems, because I think it'll actually make more sense to you if I do it that way. I will mention what the steps are, and I did just go through the steps, so I'm just going to briefly go over these. The first thing you want to do is understand the problem, always. That means that you're probably going to need to read it more than once. Read through the whole problem, highlight what seems like important information to you. But since you're going to have to choose variables to represent the unknowns, you definitely want to highlight what the unknowns are and maybe right above them a little note about what variable you want to use for that. And in this particular one, notice that we constructed a drawing because sometimes that helps. You can actually see better what the problem's talking about if you make a picture of it, or if you're given a picture of it even. The second step is translate into equations, because you can't get an answer to a word problem until you get it turned into an equation. This will probably take the longest for you to do, is to actually translate the problem into an equation. And then once you get that equation, you solve it. And then the last step And honestly, the most important step is to interpret the results, which means that you have to state your conclusion. Don't tell me W equals 11, because I didn't ask you what W equal. Problem asked us what was the width and what was the length, and we needed to answer that question. So I'm going to follow this process and do some more problems. And the one thing I am going to tell you is that word problems, no one looks at a word problem and knows automatically how to solve it. No one. Not a math teacher, no one. It is a time-consuming process. Be willing to spend 3 or 4 minutes at least just trying to figure out what the problem tells you. Word problems are not instantaneous solutions. You've got to be willing to put in the time. There is a theorem. This is actually a geometry theorem we're going to talk about now. It's going to help us with solving this problem. The theorem is called the Pythagorean theorem, and it only works with a right triangle. It doesn't work if you have another kind of triangle. And the fact that it's a right triangle, the only thing that means is that one of the angles, in the drawing here, it's the one that I just marked in green, is a 90-degree angle. That's what a right angle is. And basically what it does is it makes this corner square. So if you're looking at the borders of my window, these borders are all square. They're perpendicular to one another. And that's what makes a right angle. It has nothing to do with whether the angle is on the left or the right. This is a right triangle, even though the square angle is on the left. The other information you need to pay attention to about this problem is that we also have something called legs. And the legs are not the same as the hypotenuse. The reason that they're different is because the hypotenuse is always the longest side. And so you can see here that the hypotenuse on the triangle, it's also always across from the right angle. And so the one that's not across from the right angle are called legs. And if you take the measurement of each leg and square it and add those together, the sum of their squares is the same as the square of the hypotenuse. And that's what this formula tells us. A lot of times what we see this formula as is A squared, which is the measure of leg A, plus B squared, which is the measure of leg B, is equal to C squared, because generally we use C to represent the hypotenuse. And remember that C is always across from the right angle. So we'll work a problem using this theorem. It's really not exactly a theorem, it's actually just a formula. So this one says find the length of the shorter leg of a right triangle if the longer leg is 10 more than the shorter leg. So what we're going to do here is we're going to label a right triangle, and this is our right triangle, and our hypotenuse is the one that's across from the right angle. And we're told that the hypotenuse is 10 miles less than twice the shorter leg. So this is the short leg. And then the longer leg we are told is 10 miles more than the shorter leg. And that's what this says. And then the hypotenuse, which is this side, the side that's across from the right angle, is 10 miles less, so we subtract, than twice the shorter leg, which means 2 times the shorter leg minus 10. So read your problem, draw a picture, decide what your variables are going to be. X is your shorter leg. Your longer leg is 10 more than the shorter leg. And more means we're going to add. And the hypotenuse is 10 less than twice the shorter leg. And so since it's less, we subtract. Now that we've got that out of the way, we will move on to solving the problem. Okay, here's our application of our Pythagorean theorem. And remember that what it said was that if you take the 2 legs of a triangle and square them and then add them together, that their sum will equal the square of the hypotenuse. So let's try to identify what this problem is telling us and see how we can use that. So I'll begin by picking out some information that I think is important. First thing is we need to know what it is we're looking for. And that actually comes in the very first sentence. It says, find the length of the shorter leg of a right triangle. Well, the shorter leg of the right triangle down here is that one. And since we don't know what that is, the best thing to do is represent it with an X. So that's what we're trying to find. Then it goes on and gives us some more information. It says the longer leg, which would be this one, is 10 more than the shorter leg. Well, okay, well, here's the shorter leg. So that's X. And 10 miles more than the shorter leg, which is X, means we would add 10 miles to it. And then we keep reading. And it talks about the hypotenuse. It says the hypotenuse, which is the longest side, and is also the side that is across from the right angle, says that is 10 miles less, which means we would subtract 10 from twice, which means we multiply it by 2, the shorter leg. And the shorter leg is x. So drawing and labeling the picture will help you understand what it is that we're going to do. And then we need to remember what the formula says that we do. The formula says take each of the two legs and square it. Okay, so the shorter leg squared is x squared plus the longer leg is x plus 10 Please ignore my little dog Charlie, still barking at the possum on the porch. We're going to square the longer leg. And that's equal to the hypotenuse squared, which is the 2x minus 10. And it's squared. And because of all this squaring going on, we know that we're going to have a quadratic equation. And so in order to make things simpler, I'm going to multiply out all those expressions. And x plus 10 squared will be x times x is x squared. Plus 10x is plus 20x. Plus 10 times 10 is 100. Is equal to 2x times 2x is 4x squared. And negative 10 times 2 is negative 20x minus another 20x will be negative 40x. And then negative 10 times negative 10 is positive 100. And then we need that to be set equal to 0. And so in order to maximize the space that I have here, x squared plus x squared is 2x squared, and I'm going to subtract that from both sides. And I'm going to subtract 20x from both sides. And I'm going to subtract 100 from both sides. And when I do that, I will wind up with a quadratic equation that is then set equal to 0. And so 4x squared minus 2x squared is 2x squared. Minus 40x plus minus 20x is minus 60x. And 100 minus 100 is 0. We don't actually even need to write that down. So I'm going to slide that up. And the next thing that we need to do is, as this slide here says, we need to solve. And so that's what we're going to do. And we're going to solve by factoring. So we have 2x squared minus 60x is equal to 0. And we can factor out, because 2 and 60 are both even, we can divide both of those by 2. And they both have an x. So we'll factor out 2x. And that'll be 2x times x minus 30. and that's equal to 0. And by our zero product principle, we know that means that either 2x is equal to 0, but then that would tell us that the shorter leg is equal to 0, and that doesn't make any sense. And so we take the other factor, x minus 30, and set it equal to 0 and decide that x then could be equal to 30. So the length of the shorter leg of the right triangle is 30. And remember, it's in miles. So now we've solved, we've answered the question, we've translated it, but there's still one thing left that we should do. We should make sure that answer actually makes sense. And so to do that, x So now we're at the point where we need to actually try to interpret our answer. And the first thing we want to do is make sure that our answer makes sense. And so the way that I'm going to do that is I'm going to recreate the sketch of the triangle, remembering that the shorter leg we called x, the longer leg was x plus 10, and the hypotenuse was 2x minus 10. And we now know that the length of the shorter leg was equal to 30, which means that the longer leg is 30 plus 10, which is 40. And that the hypotenuse is 2 times 30, which is 60, minus 10, and that means it's 50. So let's make sure that now that we know the value of the variables, that our formula still makes sense. So what our formula says is that 30 squared plus 40 squared should be equal to 50 squared. Well, 30 squared is 900, and 40 squared is 1600, and 50 squared is 2500, and 900 plus 1600 is in fact 2500. So yes, our answer checks, and the answer to the question we were asked is the length of the shorter leg was 30 miles. And we have finished that problem. And that concludes our examples.